Alrighty, so when I'm talking about percent composition, basically what that's saying is how much of my total sample is this and how much of my total sample is that. So for example, an example I like to give, if I weigh a certain amount and I want to know what percent of me is water, I would find out the weight of me that is just pure water, and then I would divide that by my total weight. That would end up being the percent of me that is made up of water. And so that's all you're going to be doing in these problems. So for the first one, I actually give you masses, which is very nice of me because I can give you mass, or I could just give you a formula and ask for you to calculate percent composition. So in this problem, I tell you that water has a mass of 100 grams. It's going to be broken up into hydrogen and oxygen, so what you discover is that the mass of just hydrogen is 11.1 grams. So if I want to know the percent of each element, well, for hydrogen, I know that the mass of hydrogen is 11.1. I know that the total amount of the entire compound is 100. That's the mass of the water. And so what you would do is divide, and you get 0.111, and so you end up with 11.1%. Okay? Now, if we're rounding with sig figs, yes, I need to make this 10% because it needs to be 1 sig fig, but I'm more concerned with you guys right now about concepts than sig figs. So if you want to put 10%, awesome. What you now need to do for oxygen is say, all right, so if I have a total mass of 100 grams, that means that 88.9 of those grams, must be oxygen. Since 11.1 of them are hydrogen, 11.1 plus 88.9 equals the total 100 that makes up water. So I'm going to take 88.9, which is the mass of oxygen, and divide it by 100. And so what you'll end up getting for this one is 88.9%. And so using correct sig figs, this would end up being 90%, and this would end up being 10%. The main thing, guys, your percents have to add up. Okay. For the next question, if you notice, I don't give you grams like I did in this problem, which was very nice. However, it's not impossible at all. Since I give you the formula, you do actually know the mass of sodium within this compound. It's just its molar mass. And so the mass of sodium is 22.99. 0.99, and there are 2 sodium, so I'm going to multiply that number by 2. Now I'm going to put that number, the mass of sodium, over the total mass of my Na2SO4, and so I'm going to actually just do that in the calculator. So I got my 22.99 times 2, which is the mass of my sodium, so that is actually, I just did in my calculator, 45.98. And I'm going to divide that by the 45.98 that I get from sodium, plus the mass of sulfur, which is 32.07, plus the mass of oxygen, which is 16 times 4. And I end up getting 142.05. Okay. So just as a reminder, while up here I said, okay, this is the mass of oxygen, this is the mass of my entire compound. Since down here I don't actually have the masses, what I'm doing is I'm saying, okay, this is the molar mass of sodium within the compound. I've got 2 sodiums. And this is the total mass of the compound, the molar mass of the compound. And so if I take it and actually divide it now, what I get is 0.323688. Remember to move your decimal place over 2 places. So I end up getting 32.37%, so I'm following sig fig rules. And that's all there is to it. That's all there is to percent composition. If you're given mass, awesome. Put the mass of the thing you're concerned about on top, put the total mass on bottom. If you're not, just take the molar mass of the thing you're concerned about. So Na2, it has a molar mass of 45.98. Divide it by the total molar mass of the entire compound, and you'll still get the percent. Okay? And that's it.